Yeah, good morning. So today we discuss about the future worth method of comparison. Future worth method of comparison. So in the previous classes, so we have discussed about the present worth comparison. Means we have the cash flows, and we are evaluating the alternatives. We are evaluating the alternatives at time zero, at time t is equal to 0. So alternative 1 and alternative 2, and what is the present worth of this alternative 1 and what is the present worth of alternative 2. Then we can find out which is the best based on the, is it a revenue dominated or a cost dominated cash flow diagram. Based on that, we are going to choose the best alternative. Similar to that, we use the here the concept is future worth method. Future worth is nothing but we are going to find out at the end of the life, at the end of periods or number of periods which you are taking, that is the n is the number of periods, right? So that at the end of n periods, what is the future worth of the alternative? Means here we are calculating the f value. P is given and the cash flows are given, and then we need to find out what is the future worth of this alternative. So all the future worth we are going to find out for the different alternatives, and then which is the gives the maximum future worth in the case of revenue dominated or profit oriented. Then we look at the maximum future worth. If it is a profit oriented, okay, profit oriented, then we'll be looking at the minimum future worth in the case of cost oriented. Means when you are trying to reduce the cost, then we'll look at the which is the minimum future worth it is having, that will be considered. If it is increasing the profit or increasing the sales or increasing the revenue, so then we can use the maximum future worth of the alternative. So that is how we can choose the best alternative in this future worth method of comparison. Similar to that, which you say the cash flow diagrams, which you have the revenue dominated cash flow diagram, where the cost say it is a P and we have the revenues, say for example R1 and R2 and so on, we have say Rn. So there are, and also we will be having the some salvage value also, say for example this is the salvage value. So what is the future worth we are going to calculate for this particular alternative is, so assuming that this is a revenue dominated, so cost will be taken as negative. So I'll write the equation minus P plus R1 into, so what we are going to for this cash flow, what is the future worth we are going to calculate. So it is nothing but compounding. It is nothing but compounding. How we are going to calculate the compounding? F is equal to P into 1 plus I whole to the power of n. Similar to that, similar to this equation, R1 into 1 plus I to the power of 1, because for the years we can say for the years which is minus P, it is the present worth we are going to calculate for the what do you call, at the end of any, we are calculating the future worth. So what is the total time we are going to get? Minus P into 1 plus I whole to the power of n for n years. So this is 0 and 1, 2 and so on n years. For the n years, total of n years for this cash flow, and plus R1 is because 1 year is over, so it will be left over with the n minus 1 years. N minus 1 years, 1 plus I whole to the power of n minus 1 plus R2 into 1 plus I whole to the power of n minus 2 and so on, plus Rn means for the at the end of is nothing but 1 plus I whole to the power of n minus n, that will become 1. So that's why Rn will be the next, and salvage value will be say yes. So here the factor which you look at, we are going to find out the compounding factor, compounding. So R1, for the R1 it is R1 into 1 plus I whole to the power of n minus 1. For this cash flow, what is the future worth for this cash flow? What is the future worth for this cash flow? Means say F1 and F2 and so on. So likewise we are calculating the future worth of these each cash flow, then we are going to find the future worth of for that particular alternative if it is a revenue dominated cash flow diagram. Similar to that, we can use the cost dominated cash flow diagram and cost dominated cash flow diagram. In that cost dominated cash flow diagram, we'll be having the P at time 0, at 1 we'll be having C1, say C2 and say C3 and so on. We'll be having Cn, and also you'll be having salvage value, say for example. Okay, So in this case, how to calculate the future worth? Future worth for the each alternative. So for P, because it is a cost dominated, I'll be taking as a positive. So P into 1 plus I whole to the power of n. Then cost C1 into 1 plus I whole to the power of n minus 1 plus C2 into 1 plus I whole to the power of n minus 2, and so on. Cn into Cn into 1 plus I whole to the power of n minus 1, that will become as like this, like that only. And here the salary value is a revenue, so that will be taken as negative. So minus yes, minus yes. So this is how we are going to calculate the future worth for the, if it's revenue dominated or cost dominated. And if you have annuity, so you can use the factors. Say for example, this itself C1 is equal to 2 is equal to, and so on, 3 is equal and so on. N represents the annuity, this represents the annuity. If it is different, then we can say separately. If it is different, we can separate like this. If it is same, then we can use the equation directly. One equation, that is your worth is equal to P plus A into what we're going to calculate F by A comma I comma N, and then minus S. So if you have like this, it means all are equal, C1 is equal to C2 equal to, and so on Cn, then I can use the future worth calculation as P plus A into F by A comma I comma N minus S. Similarly, in this case also, if you use the R1 is equal to R2, R3, and so on, Rn, both are secondary, say A. If you say A, then in this case also we can write the future worth equation is equal to minus P into 1 plus I whole to the power of n. Of course, here also P into 1 plus I whole to the power of n. Then plus A into F by A comma I comma n plus S. So this is how we can use the future worth equation in the calculations. So now we take one example of this future worth calculation. Say for example, yeah. So we'll take one example here. Say for example, a man having a site, he has to decide on building gas station. So in his site, he wants to start with building a gas station or some other building, say soft ice cream stand. So there are two alternatives, say alternative 1 and then alternative 2. He wants to start with doing something on his site. So what is the first cost for this building a gas station is going to be around, say it is 20 lakhs, say for example 20 lakhs, and then annual income. So annual income for this case you'll be getting around, say for example 8 lakhs. And then say for example you are paying the taxes, of course annual taxes, which you have the taxes is payments, say around 80,000, and life of the building or service life of the building, say for example he has given as 20 years. Then say a salvage value, salvage value for this case it is 0. And say first cost in this case of building a ice cream plant, so a small scale industry in that particular site, then he wants to invest 36 lakhs for building small industry, ice cream industry, say for example. And then what is that annual income which will be having is, say for example 9,80,000, and there are taxes which need to be paid, so 1,50,000 annual taxes. These are all annual taxes, and life is going to be of course same I am taking here. And then salvage value for this also it is 0. So now So he's asking the way, which one I have to invest, on which you have to invest. Either I have to invest on building a gas station, or I have to invest on the building a small industry like ice cream production industry. Say in this case, what we have to suggest based on the investment which he has made at the beginning, and what is the future worth of these two alternatives for the life of 20 years, for the life of 20 years. So in that case, which alternative will be the best? So that for that, first we need to do what is the, say, alternative one. I'll write the alternative one. In this, alternative one is nothing but building a gas station, building gas station. So he has told that, and given data for this, given data for this is, first cost is given as around 20 lakhs. First cost is given as rupees 20 lakhs. That is nothing but P is given. P is given. So first cost is nothing but P. Okay. So now we have given net revenue. We can take it as, we can say net revenue, because there are annual income. There is annual income minus the tax payments, so it will give the net revenue, because both are annual, so annual income is going to be, it is given as 8 lakhs, it is given as 8 lakhs, then rupees 8 lakhs, and then tax payments are there 80,000. So if I take this, then I will be getting around annual, I mean this is the net revenue at the end of every year. At the end of every year, this is the net revenue. Say I can take it as R is equal to, here it is a same, every year it is a same, so I can take it as A, annuity means annual revenue is 7,20,000. For every year it is 7,20,000. And also he has mentioned that life is 20 years, life is 20 years, and the interest rate, of course I have to mention, interest rate is 12% compounded annually, 12% compounded annually. So this is the data which is mentioned. Then we need to find out what is the first cash flow diagram to be drawn. So that is the cash flow diagram. So based on this given data, based on the given data, I can say at time 0 means the initial cost, it is around 20 lakhs. It is around 20 lakhs rupees, 20 lakhs. At time 1, you will be having the net revenue. Net revenue is shown as 7,20,000. 7,20,000. Similarly, at the end of second year also we have rupees 7,20,000. Any other cash flows are there? So nothing is there, but I will give a breakup and then I'll show at the end of 20 years also we will be having 7,20,000 rupees. There is no salvage value, so I can keep as it is. I can keep as it is. So this is I is equal to 12%. At I is equal to 12%. So I have drawn the cash flow diagram. So it shows that it is a revenue dominated cash flow diagram. So in the case of revenue dominated cash flow diagram, you will be having the equation for this alternative calculation of future worth for the alternative one at I is equal to 12%. At I is equal to 12%, you can say it is a revenue dominated, so cost will be taken as minus 20,000, sorry 20 lakhs, sorry 20 lakhs into that is okay. I'll write the equation first, then I'll go with substitution. I'll go with substitution. So minus P into 1 plus I whole to the power of n, or we can write the formulas also. Okay, then plus, then annuity into we can write as, we are calculating the F for the given A, I comma n. So in this also, this one also I can write as minus P into, here I am going to calculate for AF, and given is present amount F by P, comma I comma n. So plus A into F by A comma I comma n. So I can use the factors here. So this is compounding factor, both are compounding factor. So this is uniform series compounding factor, and this is single payment compounding factor. So both I can use for the equation, say minus P in the sense 20 lakhs, then F by P, I is 12%, then N is for 20 years, then plus A is 7,20,000, then f by a comma 12 comma n is going to be 20 years. So for this, from the compound interest table, we can find out the value of this. You can find out the value of this. So what is that value? F by p comma 12 comma 20, you'll be getting around 9 point, okay, you'll be getting around 9.646, 9.646, 9.646. Okay, so plus then you'll be having rupees 7,20,000. Then FIA, comma 12, comma 20 for the rate of interest 12. Then for the service life of 20 years. Then look at the factor F by A, comma 12, comma 20. So then I'll be getting 72.72.05. So this is 9.646. Both are obtained from the compound interest tables. These two are got from the compound interest tables. Now, if you find out this calculation and all, I'll be getting around rupees 3 crores 25 lakhs 85,000, then 440 rupees. So this is the future worth of this particular alternative one. And similarly, we need to find out the for this alternative 2. What is alternative 2? Alternative 2 is building ice cream plant. Alternative 2 is building ice cream plant. So for this, we have the initial cost, alternative 2. So given data, what is the given data? Is first cost, that is nothing but P. First cost is nothing but P, which is given as rupees 36 lakhs. 36 lakhs. Then we know that revenue means annual income is there, as well as the tax payments is also there, because both are annual. So I can take it as net revenue. So which will give the rupees 9,80,000 minus rupees 1,50,000. So in this case, I'll be getting rupees how much you are going to get? 9.8 minus 1.5. So 98 means 7. 3 will be getting as the net revenue, and this net revenue is per annum, so per every year. So it will be taken as annuity, means annual income after paying the taxes. So we'll be getting the A as rupees 8,30,000, and life is of course 20 years for both, and I is also same for the both alternatives. Now we need to draw the cash flow diagram. If you look at the cash flow diagram, so this is the initial cost which is to be made at time zero, which is rupees 36 lakhs is the investment which has made, and also he is having the annual income is going to be around 8,30,000. Here annual income he has got rupees 8,30,000. Similar to the procedure present worth calculation, only thing is we are going to calculate the future worth, means compounding calculation. It is nothing but compounding calculation we are doing. So rupees 8,30,000. Okay, then and so on, you will be having say rupees 8,30,000. There is no salvage value here, so salvage S is equal to 0 in this case, as well as in this case S is equal to 0. Then I is equal to 12%. This is the cash flow diagram for the given problem. Now we'll move to the calculation of future worth for the given cash flow. So how to write the future worth equation? So future worth equation, if you take future worth equation, FW is equal to, for the alternative 2 at I is equal to 12%, I can write for P this, because it is also revenue dominated. So I'll write minus P into, because we are calculating the future worth and for the given present value, and I comma N, plus the revenue is annuity. It shows the annuity. So A into, I can write, we are going to calculate the F by A comma I comma N. So substitute this in this equation. So rupees minus, of course I'll substitute this minus 36 lakhs 36 lakhs into F by P, comma I is 12, comma 20 plus rupees 8 lakh 30,000, 8 lakh 30,000 F by A, comma I is 12 and then 20. So if you look at this, we have the same factor here and there. So I can use the minus 36 lakhs then into 9.646 is the factor which I'm using, then plus 8 lakh 30,000 into the same factor which I'm going to use is 72.052. So this is the calculation which you need to do. Now if you look at this by multiplication of all this, I'm going to get around rupees 2 crores 50,077, I mean 50 lakh 77,560 rupees I'm going to get from this FW2. So now if you look at the two alternatives, one is alternative 1, FW1 is this much, and that is 3 crores, and FW2 is gives the rupees 2 crores 50 lakhs and 77,560. So by comparing these FW1 and FW2, so because it is a revenue dominated, so which gives the more future worth, that will be chosen as the best alternative. So the future worth for the alternative 1, the future worth for the alternative 1 is higher than future worth of alternative 2. Hence we can suggest building gas station is the best alternative, so that is how we can choose the future worth method of comparison. So here the calculation part, we should look at the change in this case is going to be the equation of future worth calculation, So the equation in the present worth calculation, we are calculating at time equal to 0, and whereas here calculating at time is equal to n. So that is what we can say at the end of n years, we can call it as compounding. That is how we are going to calculate in this future worth method of comparison. So now we'll move to the next payback comparison. Payback comparisons are nothing but, so we are going to invest some amount of say money, and how much time it will pay back in the sense how much time it will take return the amount. See the payback comparison method. The payback comparison method means, if the names here, if you look at the payback means return, it is nothing but equivalent to return on how much you have invested, then when I am going to get my returns. Say for example, you have invested 1 lakh, then the returns will be generated after some years, right? That is what the period, that period is called as payback period. That is what is called as payback period. So the investment will pay for itself, say for example in 2 years or 2.5 years, or say for n years also. So we need to find out for any investment which you have made in any business will take some time, right? So before it starts giving the profits. So that is what we can call it as payback. So in order to find this rough duration or rough estimation of time, how much it is going to be, when it is going to be give the payback, when it is going to give the payback is called as payback period. Payback period is nothing but it is an estimation of the time before a proposed investment begins to show the profit, right? So if I look at this formula for this payback period, which is given as the required investment, how much you have made the investment, and divided by Annual receipts and debentures. Annual receipts means how much you have receiving, that is the revenue, and annual debentures means how much cost debentures. So receipts and expenditure, okay, receipts and expenditures we can write as payback period is equal to, we can say, for example, P is the required initial investment which you have made, initial cost which you have made, and what is the amount we are going to generate from that, that is the revenue, or we can say the cost or expenditure. So P by this is revenue minus cost is nothing but savings, right? So net savings, so P is nothing but it is a initial cost or first cost, whatever you can say, is the investment which is made at time it is equal to 0, and based on this revenues and cost, so at what time, at is the what is the rough estimation of time, at what time it is going to generate the profits to the investment made. So here the payback period can be used to compare the alternatives as well. Similar to that, what you can use till the future worth comparison and all those present worth comparison, how you compare the alternative based on their present worth and based on their future worth. And the payback period is also what is the time, stipulated time for giving the profit. Say for example, alternative 1 and alternative 2 you have, so based on that which alternative will give the profits in a early manner, so that we need to we can find out by using this payback period method. So if you take this payback period method, in this case, say for example, I have taken, there are three machines. One example we'll take so that you can understand what is payback comparison method. So here, if I have machine A and say machine B and say machine C. So there are three alternatives for any for industry it is having. These are the machines which have to be invested. And what is the initial investment or first cost on this? First cost on this is going to be, say for example, 30,000. On the machine A it is 30,000 rupees, 30,000, and machine B it is rupees 38,000, and say rupees 42,000 in the machine C. And then what is the annual receipts I'm going to get from this? Annual revenue or receipts, we can say annual revenue, which is nothing but, as mentioned, rupees 20,000 on this, and rupees say 23,500 on this, and rupees say 26,000 on this. And if you have expenditure, annual expenditure on these three alternatives, it is, say for example, rupees 5,500. Then it is on this we have rupees 6,500, and on this we have, say for example, rupees 7,000. And the economic life or service life of this machines, service life of the machine is taken as, say 4 years. Say 4 years for these all the three alternatives, 4 years. Then you need to compare these three machines, and which will give the early payback period. Early payback period means which you need to find out the payback period. Here we need to find out the payback period for each alternative, and then choose the minimum payback period which is having, because minimum is time period. Say for example, for this is say 2 years, and then they say for example 3 years, and then say for example 4 years. So at the end of second year only the machine A is gives the profit, starts giving the profits. So we'll choose this. So whichever the payback period is having the minimum payback period or time, so that will be chosen as the best investment. So here, how to calculate this payback period for each case? As we have the equation, the payback period is equal to P by revenue minus cost or net savings. So using that equation for machine A and for machine B and for machine C, we are going to calculate. So using that equation, so first machine A, what is given? So first cost, that is, I can take it as P, which is given as rupees 30,000. This is the data which is mentioned. And annual receipts, nothing but it is a revenue according to this. R, so I can take it as rupees 20,000, and annual expenditure or cost, we can say it is taken as C, which is rupees 5,500. And service life is given as, of course, 4 years. 4 years. So now we have the equation, the payback period for this alternative machine A. Machine A, yeah. So we can use the equation payback period. Payback period is equal to first cost divided by net savings. Net savings, R, that is equal to P by R minus C. P by R minus C. So what is the P value here? 30,000 divided by R is 20,000, then minus 5,500. So here I around get 30,000 divided by 14,500. 14,500. So roughly around get 2 point something, 2 point something, I can say 2.06 years. So I can take it as 2.06 years. Okay, 2.06 years. That is for mission A. Payback period for mission A. Payback period for mission A. Similarly, I'll go for calculating the machine B. So machine B, which is having the initial, that is first cost for the machine B, is given as first cost. I'll write as first cost, which is equal to P, in this case rupees 38,000. Rupees 38,000. And what is the receipts or revenue? Annual receipts or revenue. Annual receipts or revenue, which is given as rupees 23,500. And annual expenditure, which is taken as C, that is equal to rupees 6,500. Rupees 6,500. So when you take this, and the service life, of course, service life is given. What are the data given, that will write, even though it is not required in your calculation, just write down the service life is. Now what we have to do is, we are going to calculate the payback period. Payback period equation is written, that is first cost divided by net savings, which is equal to P by R minus C. So we are going to calculate the payback period for the machine B, which you can find, say, by using that equation, simple equation. So what is the first cost? It is around 38,000, 23,500 minus 6,500. So 500 if 23 minus 17, you are going to get around 38,000 divided by 17,000. So around you'll be getting 2 point very here 2 point something, 2.23 2.23 years. So this is the payback period for the machine B. Similarly, for machine C, I'm going to calculate for machine C. Using machine C, okay, and we have the first cost, which is equal to P, that is equal to, we have got around 42,000 rupees, 42,000. Write the data, okay, write the data, and then we have the annual expenditure, which is equal to, say, annual receipts, we can say receipts, which is given as, say, R, it is equal to rupees 26,000 we have. Then annual expenditure, which is, say, C, rupees 7,000 we have. So now life is equal to 4 years. And then we can calculate the payback period for this. Payback period is equal to that is net savings, first cost divided by net savings, that is P by R minus C. which is rupees, 42,000 divided by 26,000 minus 7,000, which will be around 42,000 divided by 19,000. So 2 point, how much you're going to get? 2 point, say 2.21 years. So by looking at this is a payback period for the machine C, which is 2.21 years. So payback period A is 2.06 years, and payback period for B is how much it is? 2.23 years, and then payback period C is going to be 2.21. So which is the best one? So payback period which gives the returns on investment at the early, means at the end of 2 years, 2.06 years, it gives the returns. So with that we can stop today.